All right, once again, I'm back again, and we are here. It's Trinity Tribe, and I am Trinity once more again. We looked at Hooke's law last time, and we spoke about what Hooke's law says. I explained in the first video how that Hooke's law tells you that the amount of force you apply to an elastic material is equal to the extension of the material. And I explained that force is the same thing as tension. I explained that tension is the same thing as force. Then extension is increase in length. So we want to actually go over this whole guide here. Alright, these basic things you need to know. These are the basic things you need to know. Then we go over this. Alright. Now we solved a question last time. So the question was solved in the first video. We also solved this question as well in the first video. We solved this question also in the first video, and now I need to explain the basics. We are going to solve this, but first I have to explain the basics. Alright, so the first thing we have here from this whole thing here, alright, when you're dealing with Hooke's law, the first thing you have to know is force. That's the basic thing you need to know. Force. Now, what is force? Force is the same as what? Same as tension. The tension. Alright? Then you have to know that sometimes you may not be giving force. Your force is already represented in Newton, right? Which is abbreviated as N. So you could be given a force of 20 Newton, 30 Newton. But there are times you might not be giving your loading unit, or sometimes the load given to you might not be in force or tension. It might be given in mass, or given as mass. And mass is measured in grams or kilogram. Any of the two. Do you understand? If you are giving your load, let's say in 20 kilogram, alright, you convert this kilogram, alright, to units by multiplying by what? 10. And that gives you what? 20 Newton. Alright. If you are giving mass in 2 kilogram, you multiply by what? By 10 to give you what? 20 Newton. Because when you are dealing with Hooke's law, the formula is what? F is equal to what? K E. And we understand that your what? Your F is force. Right? F is force, not mass. Do you understand now? Your F is force, not mass. When you are giving a question, look at these questions. Can you see that can you see that the force was in Newton, or the tension was in Newton, not mass? Also, okay, this is not Newton. Let me get this one for you. Look at this. Okay, when we calculated our answer, it was in force. So many times when you are giving your question in Hooke's law, you are expected to have force as one of the parameters. But if you are not giving force, you might be giving mass. So what you can do is that you can always convert your mass to what? To force by multiplying by what? By 10. Do you understand? Alright. The next thing that we need to know is this. And how do I come about this? Let me hear this. How do I come about all this? is because the formula for weight is mass times G. Alright. We're going to do more calculation. Your weight, listen up. Your weight, alright. Your weight is what? Is tension. Do you understand? Your tension for T is still the same thing as mass times G. Your force also still the same thing as mass times G. Do you understand? And this 10 you see here, alright, your mass can be anything, but your G will always be what? 10. Do you understand? Do you understand? So if you were given, let's say, a mass of 5 kilogram, alright, and you were told to what? Convert it. We were told to find the force, alright, convert to weight, alright, which is what? Tension, and which is what? Force, alright. Just multiply this 5 times 10 and you have what? 50 Newton. So it depends on what you are given. What you are given. It depends on what you are given, alright? Many times you'll be given force, you'll be given tension or weight. Sometimes they could mean the same thing, sometimes they could mean different things. But just know that your weight, your tension, and your force are all measured in what? Newton. And if you can't find your force in the question, you can't find your tension in the question, you can't find your weight in the question, but you find mass. Let's say you find a mass of 3 kg in the question, just convert the mass of what? To Newton by multiplying by 10 to have what? 30 Newton. Then you can proceed to use what? This formula. Do you understand? Right. Then what if I was given a mass of 3 grams? What if I was given a mass of 3 grams? 3 grams is different from 3 kg, right? The first thing I need to do is convert my 3 grams to what? To kilogram. And how do I do that? I divide my 3 grams by what? By 1000. Alright? And that gives me what? 0.0. Are we together? Okay, 0.03 kilogram. Now that I have my kilogram, I multiply my kilogram by what? By 10 to get what? Newton, which is 0.03 Newton. Can you see? So I have converted my gram. So when you have your kilogram, you multiply by 10 to get Newton. But if you have gram, which is smaller than kilogram, first convert your gram to kilogram by dividing by 1000. Then you can go ahead to multiply your kilogram by 10 to get your Newton. Now let's go to the next one. The next one now is, we spoke about force, right? Force. We have what we have here, length or distance. Okay, let's go to the next one. The next one is what? Length, distance. Now, I want you to understand that when dealing with Hooke's law, remember that the formula is what? Once again, F is equal to what? K E. So we've talked about force, right? Now I want to talk about the extension, which is E. When we're talking about, okay, look at this question. You can see length is involved in any question that has to do with Hooke's law. Can you see that length is involved, right? Your length is measured in what? It's always measured in centimeter, sometimes sometimes in meter. So your length is always measured in centimeter or sometimes meter. Alright. I want you to understand that the extension is the same as what? Increase in length. Do you understand? Your increase in length is this. Your increase in length, which is your extension. How do you calculate it? It is your new length minus old length. It depends on how the question. Now this is it. Let me explain. Imagine you have a rubber band. Imagine this is a rubber band, right? And your rubber band actually has a length of what? Let's say 3 centimeters. Now after you stretch your rubber band with your finger, your hand, you stretch to what? Let's say the new length is what? Let's say the new length is 7 centimeters. The question now is this: what is the extension? What is the increase in length? Alright. Extension is the same thing as increase in length. So I could ask you any of the two questions, it's the same thing. So what's the extension? What's the increase in length? It will be the new length minus the old length. That will be 7 minus what? 3 equals to 4. Always put your units. Always put your units. That verifies your answer is correct. Alright. So the increase in length is 4 centimeters, or you can say the extension is 4 centimeters. Now I want to look at something. This is a question. This one. A spring has an unstretched length of 12 centimeters. When you say unstretched length means what? Original length. Alright. Then it says what load is needed to stretch the spring to a length of 15 centimeters. That's the new length. That's the new length. Let me write this out for you here. Now, in this diagram I drew up here, so what would be the unstretched length? The unstretched length in this diagram is what? 3 centimeter. Then what is the stretch length? The stretch length is what? 7 centimeter. Then what is the extension? Or you can say, what is the increase in what? In length. The increase in length the increase in length is what? 7 minus 3. That is the stretch length minus what? The unstretched length. Or you can say the new length minus the old length. 7 minus 3 gives you what? 4 centimeter. 7 minus 3 gives you 4 centimeter. Alright, so I've covered what? I've covered extension, I've covered force, right? I've covered extension, I've covered force. You have okay, this is the extension here, right? Tension is what I've also covered, which is force, which is this. Alright. Then the next thing is energy and work. Energy and work. Energy and work. Okay, let's go further. Let's go further. Let's go further. Now, when you're talking about energy, when it comes to energy in Hooke's law, alright, we mostly make use of potential energy. Potential energy. And potential energy is written as, this is the formula, or this you can say this is the mathematical expression. Alright, mgh, your m is your mass, your g is your acceleration due to gravity. Which is always what? 10. Alright, 10 meters per second. Then your h is your height, or you can say your length, or you can say your extension, or you can use what? Distance. So it depends on the question. Alright. Now the next thing is work. Don't worry, we'll have questions that solves all this very soon in the next videos. This is just to explain the basic. Alright. Now you have your work, which is your work is your force times your distance. It can also be your weight times your distance. It can also be your weight times the extension. Remember I said distance is the same thing as length, extension, or height, or whatever. So just know that it has to do with length or distance. Any of them. You can still use your force times your extension. Alright. So there are other things, there are other formulas I will bring in as well. But right now, we have to stop right now. So I just wanted to teach you the basics for you to catch up as quick as possible if you don't understand all this. Okay, now let me explain what elastic limit is. Your elastic limit is more or less your now what's elastic limit? Elastic limit, all right, okay, I'll explain that in the next video to come. I want to solve for you right now, so let me give you a solution to this question. Now in this question here we have this. It says a spring has an outstretched length of what, 12 centimeter, right? Its spring constant is 8 Newton per centimeter. What load is needed to stretch the spring to a length of what, 15 centimeter? Okay, now outstretched length is what? Is 12 centimeter, right? Then the stretch length is what? The stretch length is 15 centimeter, right? Now we're given our K. Remember we have the formula what? Always remember your formula. F is equals to what? KE. So our K, which is this guy here, alright, is what? 8. Now we're being asked what load is needed. The load is in what? In force, alright, in force. Now it means we have, now you will ask me what about my E? My E is what? The stretch length minus the unstretched length. So if I scroll down, my E is what? 15 minus 12, which is what? 3 centimeter. So I have my K, I have my E, now I need my F. F is equal to what? KE, F, which I need, I can find it by multiplying my 8 times my what? My K is my 8, my E is my what? 3. And what do I have? If you don't have a calculator, use a calculator. If you want to use a calculator, I think I should calculate so that you can see how it's done. Right, that is 24, right? Okay, now what is the unit of force? Newton. So the answer to this question is 24. Can you see? So you will need a what? A force of 24 Newton to stretch this spring from 12 centimeter to 15 centimeter. Now let us look at a simple animation to practicalize what we just solved. All right. Now if you look closely here, this is a spring, all right? So we are saying that our spring has a force constant of 8, right? 8, right? Okay. And we're told that it requires 24 Newton. Let's see what we can do here. Oh, okay, it's very, the highest we have, the lowest we have here is 100 Newton. 100 Newton. But let's keep it at 100 Newton. Let's apply a force of 24 Newton. Can I click this? I can't click it. Alright, 24 Newton applied force. You can't go below it, unfortunately. I can't go below 100 for the spring constant. Now you can see that as we keep on stretching, as we keep on applying more force, you can see how the spring stretches. As we reduce the force, you can see how the spring goes back to its original length. What if I, okay, alright. So I will give you more examples of this in the next coming videos. I have to end the video now, so it won't be too long. Alright. My notes to this lecture is in the link below. I want you to like this page, share this page, subscribe to this page, tell your friends and family. If you have parents who need home tutoring for their children for physics and maths online, you can help me make the information available to them as well. Thank you very much. See you next time again.